Okay, good evening everybody. This is supposed to be a longer presentation, but I only have 35 minutes, so I'll try to speed up. If you have any questions, please feel free to reach out after the talk and I can help answer them. So, welcome to Bug Bounty Hunting on Steroids. We are actually a team of three. Mohammed is in Egypt, Glenn is in Australia, and I'm from San Diego. Unfortunately, those folks couldn't be here, so I'm here kind of representing everybody. I'm basically a security engineer by day. I do product security, application security, which is pretty much responsible for everything. And then after hours, when I'm not doing my full-time job, I actually hunt for bugs. So I'm actually a bug bounty hunter. I hunt on Bugcrowd, HackerOne, all the platforms out there. I believe in automation. I try to automate as much as I possibly can. And I also believe in all things as code. So infrastructure is code, automation is code. Because I'm lazy and I just like the computer to work for me. I don't like to do the work. So it's just a little bit of introduction about me. So today's agenda, we'll basically go through the problem statement. We'll walk through what the current situation looks like. We'll actually hack, or we have a company set up, and we try to show how to hack a company that has a bug bounty program. And then we've built this framework. We call it the bounty machine. So I'm actually going to walk through the architecture, show it in action, and then just briefly end the presentation by lessons learned and some conclusion. So to start with the problem, I mean, we all know that not all the hacking that we do is fun, right? We do a lot of same things on a daily basis. And those are some things that we really want to automate, right? Like finding low-hanging fruits and like things that can be easily automated and can be found. The second problem is if we identify a problem that needs to be solved, we mostly try to build something from scratch. Now that's not a great idea because if you just go online and search for open source tools, there's plenty of tools out there that can do the exact job that you're trying to do. So building something from scratch is a very bad idea, and I wouldn't recommend doing that. The third is often as security engineers, we have some small shell scripts, bash scripts, and we have those scripts focused on one particular, let's say, IP address or domain, right? How, as we security engineers, want to scale it across a big company or big enterprise, or even multiple IP addresses and domains. So the horizontal scaling as well as vertical scaling is something that in the security industry we don't see that quite often. So we've tried to solve that problem by building this framework. And then the last thing is, with the advent of all these cloud providers like Amazon Web Services, Google Cloud Platform, we see that things constantly change. There are new IP addresses, there are new domains, right? So we as security engineers, we're supposed to make sure that we actually go through all the attack surface and we make sure if something changes, we get alerted because of that. Right? So these are some problems that we see in not only bug bounty industry, but also the security industry in general. Oops. Right. So walking through some of the current situation that we have, the state of open source tools is very sad, unfortunately. You'll find that there are so many tools that do the same job, and tools basically have the same functionality. So we see that there's a lot of redundancy between tools, and that's something that even if it's a security engineer, they would struggle to figure out exactly what functionality works for one tool and what doesn't, right? So we have to solve that problem some way or the other. This explicitly, I feel, represents a situation very, in a very right way. Basically, so imagine there are 14 tools out there, and all of them do like similar job. And then there's this person out there, there's a hacker. He wants to add a new functionality, right? And then he goes and searches on Google, and he finds all these 14 different tools, and then he thinks, maybe he can add a new functionality onto one of those 14 tools. What ends up happening is he ends up writing a 15th tool. So this is exactly how we constantly see the same kind of tooling being open sourced again and again, and there's no ideology of basically improving what we have instead of building something from scratch. So this is the state of open source tooling, and we have to improve that. And then the next point is lack of reliable tool comparisons. Like, how do we know which tool works for us, which tool doesn't work for us? There's no framework, there's no standard, there's just open source tools out there that we as security engineers are supposed to be using on a daily basis, but we don't have any standard to compare against, right? So the situation is improving thanks to our very own Jason Alex. He is, he has a lot of stuff. I can't basically list all of them here, but he basically has the bug hunters methodology. He actually explains, the different tools out there, how do you approach them. They have an entire training course in the other room for Bhartiya University. I would highly recommend to go watch it and learn something out of it. This is actually a slide I stole from you, Jason, but he actually compared the different tools, how fast they are, how many subdomains they can find. So this is the sort of analysis or research that we security engineers really need, because there are so many tools out there. Which one do we know which to use? So I think something like this is really helpful, Jason. So thank you so much. Moving on, we often see that with all these open source tooling, we often find that these tools don't operate well with each other. What I mean by that is there might be tool A that produces a certain output in, let's say, JSON or CSV, right? And if we want to combine that output from tool A and feed it into another tool B that does not really ingest CSV or JSON, we are basically stuck, right? We have to manually run tool A, take the output, and then feed it into tool B manually. So the entire flow is actually broken, right? Because there's no standard again. And this situation is also improving. There's actually a GitHub project. It's called ROOTCON JSON. It's actually started by one of the bug bounty hunters, and the idea is to basically create a standard or build a standard around how different tools should work with each other, so that we as engineers or hackers can actually concentrate on the workflow, on the hacking, and not care about if tool A will work with tool B or not. So there has to be a standard, and I'm so glad this actually started. So kudos to that. And then scaling and reliability, I spoke about it earlier, but this is one of the biggest problems in the infosec industry, where we have all these security tooling, like even big enterprise tools like you name it, scanners, Nessus, Qualys, right? When it comes to scaling and when it comes to accurately predicting or finding good vulnerabilities, they often fail. And we all know that we have these tools for compliance for the most part, right? And that needs to change as well. So how do we bring that scalability factor into this? So I'm not going to go through this, but just the idea of vertical scaling, horizontal scaling, is really important. And what we have tried to leverage in the boundary machine is we went to the development side of the world, and we took some ideas from there. Like, how can we bring those ideas into the security industry and make sure we can actually scale them? And I'm actually going to walk through some of those technologies later on. And then finally, we as hackers, we just want a research environment that we can just go and hack things, right? So don't you think it will be awesome to just have a database that just stores all the asset information, all the recon information, right? Don't you think it will be awesome to have a platform that supports basically receiving all the artifacts that are being gathered from the tools, and then just an easy way to explore what's out there? This is exactly what we wanted to go after, and I believe we have built a solid prototype of it. So, and then one final point is, it's all about identifying assets, right? We all know reconnaissance is king. You cannot hack something if you don't know what you have, right? So that's exactly what it says here. What you don't know about, you cannot protect. So reconnaissance is the most important thing, and I want to stress on that when it comes to bug bounty hunting, or even just like any sort of security, practices in general. You should know what your assets are, because if you don't know them, there's no way you can try to predict them or make them more secure, right? This is just basically a survey that OWASP did, but basically, the question of which of the OWASP top 10 caused the world's biggest data breaches, and this shouldn't be surprising, but almost 50%, you can see 24% using known components and 3% using security misconfiguration. So you can see almost 50% of the total number of breaches are because of things that exist in your infrastructure and you just don't know about them, right? Like using components with known vulnerabilities are basically things using outdated JavaScript libraries or just using outdated, software that you shouldn't be using. And if you can fix them, you're going to take care of 24%, right? And the next point is security misconfigurations. Again, simple, low-hanging stuff that can be easily automated and fixed. So just think about that, and 50% of most of the features just go away like that. Theoretically, right? I know it never happens, but so and then so like I mentioned, with the advent of cloud providers, there are the new assets, there are new hosts, cloud services, subdomains. There's new code constantly being pushed up. Everybody's trying to follow the agile way of doing things. There's hundreds to thousands of code pushes on a daily basis. Just imagine the amount of security holes or vulnerabilities that kind of introduces, right? And what kind of regressions it can possibly cause. So we as security engineers are supposed to take care of all of that. So that was just the introduction. Now it's the actual fun part, right? So basically, we have set up a company. We call it Ellingson Limited Corporation, and we will actually show you how this bounty machine is going to find or is going to basically automate most of the low-hanging recon stuff and just spit the data out to you, which you can then use to do whatever you want with it, right? So we have this company. We just know two things about this company. There is a GitHub repository. It's called Ellingson Corp. It's online right now, so you can go check it. And there's a main domain, ellingsoncorp.com, right? This is just two pieces of information that we know about this company. And this is often the case when you go hunt for bugs, right? You are just provided a domain, or you just provided like one piece of information, and you as a hacker are supposed to go find stuff on it, right? Oftentimes you will see people are intimidated. They're like, where do I start? This is used. Where do I start? Right? So I'm actually going to show how easy it is to do that, right? So because I don't have a lot of time, I was actually going to do a live demo of it, but I also have a recorded demo, so I'll just show you the recorded demo. But basically, before I show you, right, I just wanted to walk through the architecture of what this machine is doing and how we have built it, right? So we call it bounty machine because it's a machine and it spits out bugs that we can report and get bounties, right? Just as simple as that. Some of the technology, so I mentioned earlier, we went to the development side, we borrowed some technologies from there. So the entire framework is written in Go, and these are some of the features of Golang. It's already out there. It's fast, it's concurrent, it's cross-platform. You can make it run in Windows, Mac OS, whatever it is. It has good error handling. It's just some awesome features. So if you ideally want to build something that is scalable, Golang is the language I would recommend. The next technology is containers, right? I didn't see a lot of container-based presentations this conference, but Docker container is something that is getting a lot of attention these days, right? And we security engineers are mostly afraid and skeptical of going that route because it's still, a domain where people haven't really explored how secure, how can you actually secure, right? But what we ended up doing was we actually used the containers, the entire technology around containers to basically do most of the scanning and scale it out, right? So it takes care, so these are some of the features of using containers. It takes care of all the dependencies. You don't have to worry about operating system. You don't have to worry about different versions, right? It just works. You build a container of it and you run it and it just works. So it's easy to spin up and down. You can basically replicate your staging environment with the production environment, and vice versa. It is maintainable, right? You just update a small change, you build a new container, you still have the old container. So there's some good features when it comes to containers, and we've used that. The final, this is actually the third technology, but in order to orchestrate all those containers, you need an underlying framework, and that's why we use Kubernetes. This is, you can think about it, it's a very complex technology, and I'm not going to go into too much details of it, but you can just imagine Kubernetes as the underlying orchestration framework that takes care of the containers like running on a cluster. So you don't have to worry about the IP addresses of the containers, how do they communicate, how do they expose services. Kubernetes just makes it so much easier for you. And with AWS and GCP, they have managed service offerings. So all you have to do is you just have to go and start a Kubernetes cluster, and that's it. You don't have to worry about anything else at all. And the last technology that I'm going to talk about is Argo. So again, all these technologies are on containers, right? Argo is basically a workflow engine that is built on top of Kubernetes platform. And I'll show you how this is helpful, because you can actually create complicated workflows when it comes to finding stuff, right? So if I wanted to find all the subdomains of a main domain, right? I don't want to run just one tool, right? So I explained, I want to run tool A, take its data, feed into tool B, take its data, feed into tool C, so on and so forth. And just orchestrating all these different containers is a very difficult problem, and Argo helps us solve that. You can actually define a workflow file and it just works. So I'm just going to show you what that workflow file looks like. So this is actually a sample Argo workflow file, and in this file I'm just scanning all ports, 65535 ports, right? So you can see I have multiple steps defined. The first step is I run nmap on the first 3000 ports, right? I want to do that because I want to run nmap fast and have data as soon as possible. I can't possibly imagine running nmap against all ports and expecting it to spit out data immediately, right? So I run nmap, I convert the output of nmap XML to CSV. I then feed that CSV into a different masscan, and then I use masscan to scan all the remaining ports, right? And then I finally combine the output from nmap and masscan, and then I feed all the port scan output into a different tool altogether. So you see how easy it is. If you wanted to build your own port scanner, you can just do that by adding a new step here, and it will just work, right? And you might be thinking, okay, this is just me defining tools, but where are the tools mentioned, or what will the tool do? So if we scroll down further, you can see that all these individual tools have their own specifications, right? So for nmap, I'm going to run that container, which I have hosted in my Docker Hub, and I have provided all the arguments it needs, right? So this is all you need to do. You need to have a tool, you need to build its container, you need to host that image somewhere, and you just need to specify that. And just specify everything in a workflow file, and it just works, right? So this was just a sample workflow file. I don't know how much time I have, but I'll save the fun part in the end, but just going to briefly go through the architecture of how it all works, right? So it all starts with like a main domain or a main IP address, right? So you feed that main thing into a worker. So we have defined the concept of different workers. Each worker is supposed to be doing one specific thing, right? So we have this concept of input worker, which just takes input and drops it into a queue, right? So the data from the queue is then picked up by a workflow worker, and this workflow worker is exactly the Argo workflow which I mentioned earlier, right? So imagine creating different workflows here and have this worker spawn those different workflow files. So you're basically doing horizontal scaling as well as vertical scaling, because this is just a container. You can start another container and that can spawn another workflow file, right? So the idea is to take that input, start a workflow worker, and then so whatever the output this workflow generates, it drops it into a different queue, not this one, and then from that queue, it's consumed by a different worker. So now in the bug bounty industry, right, we don't want to do scanning 24/7, right? We want to do scanning, but we only want to know if something has changed, right? If you keep seeing the same results again and again, you will be confused as to what's changed, what should I report, what should I not report, right? So we've built this different worker that just compares the old results from the new results, and it just drops the difference into a different queue. And then from there onwards, the data into the difference queue gets picked up by a different worker, which all it will do is it will just send you alerts. It can be Slack, it can be like a web UI, it can be a CLI, right? So you're seeing how extensible this whole architecture is. All these workers are just containers. You can build your own worker, it just works. So if I sort of combine the entire workflow end to end, this is how it looks like, right? And all these different components are just different workers built as containers. You start with the input, it gets dropped into a queue that gets consumed by a workflow worker. Workflow runs, it gets dropped into a difference worker. You get back only the differences, which is then consumed by the notification worker. That's it, right? So this was really the architecture of boundary machine. Now let's walk through the demo, which is the fun part, if I can get to it. So this basically this runs for about 15-20 minutes. I don't have that much time, but I hope this is visible. There's not much I can do over it, but I can try to walk through it. So basically, I just issue a Slack command and I provided the main domain, which was linksincard.com, right? And I just start that workflow. And then I also provide the GitHub repository. So there are just two things we knew about this, right? The GitHub repository and the main domain, right? Let me pause that. Yeah, so there were just two things that we knew about this company, the main domain and the GitHub repository. And I just provide both those input into my Slack frontend, right? And you can see the first workflow ran. I don't know if you can see or not, but it's basically spitting out. Right. Okay. So where was it? Right. So you can see that when my Git secret worker ran, it actually scanned that organization's repository. It scanned all the users inside that repository. It scanned all the repositories of each user, and then in the end, it eventually found a secret hidden somewhere in like one of those repositories, and it just sent me a Slack output, and I can see that the secret was there, right? Moving on, you can see that I also got back a list of subdomains, right? So from the main domain, I got a list of subdomains. After that, I got a list of S3 buckets, right? So now there were some subdomains that were hosting a S3 bucket, which was both writable and readable. So I was notified about all of that. Then it found out all the port scanning. So if we ran port scanning, it actually scanned all the subdomains and it reported back all the status of the ports. It then identified all the ports finding. So again, this is too fast, but you get the idea, right? So basically, we have about 30 different workflows that we run, and they just work like one after the other, boom, boom, boom. And this is what we see on our Slack, all the output, and we just take this and just go and report it. That's it. It's easy money, right? But obviously it wasn't this easy. I mean, there's a lot of work that went behind this. But let's see if I can fast forward this. And in the end, just one more thing. So I'm pretty sure you can't see it, but it identified a MySQL database running on a particular host. It actually brute forced and it found the root password. So I didn't have to do anything. I just provided a main domain and I got the brute force password of a MySQL server, which is running on one of the random subdomains. And it's all on Slack. So I literally don't even need a laptop. I can just issue the Slack commands from my cell phone and I can get back results. Right? So this is why we call it bug bounty automation on hunting on steroids, because this is just against one company. I can horizontally and vertically scale this, meaning I can run it against multiple different domains and IP addresses. And I have so much data, it's going to take me ages to just go through all of this, right? But just imagine, I don't need to think about it anymore. I have everything here, I just go and start searching for it, right? So yeah, that was the domain, that was the basically output of it, right? And just to quickly end this presentation, some of the things that we've learned, we've been working on this for almost 2 years now, and we've encountered a whole lot of roadblocks. But we discovered that we were going after the perfect product, and that didn't work. So we focused on our MVP, or most viable product. Right? We built this entire thing into different stages, and if there was anything that seemed more complicated, we just kept it aside and came back to it later. So that was something we learned. And the fact that we're supposed to move fast and not just break anything, right? So, and eventually, so we started with this, and this is what we ended up with. So just imagine, we started up just GitHub repository and our main domain, and we end up with all of this. And just quickly show all the things that we found. We found secrets hidden in GitHub repositories. We found all the subdomains of the main domain. We found different ports open, and then we ran different tools. We found a course misconfiguration on one of the random subdomains. We found a hidden file on one of the random subdomains. We found a subdomain takeover for one particular subdomain. This was also subdomain takeover. We found a WordPress blog, and we found a wildcard cross-domain or XML files. We found the MySQL weak creds that were brute force, right? We found a hidden JavaScript file that had a secret to an admin console, right? And this is again more stuff. Again, I can keep going, but yeah. So to end this presentation, what's the conclusion? I keep hearing from a lot of hunters that we can't automate everything, but I don't agree with that. I think we can definitely automate. There's so much stuff we can automate, and we should do it. And we've actually built and showed it to you that it is possible, right? And just the fact that don't be afraid to explore new technologies. Go out there, see how you can bring different technologies from different domains into the security domain, and see what cool shit you can build with, right? Keep tooling simple. Make sure you don't build like a one giant monolithic tool that is supposed to be doing everything. Make it extensible. Make it such that people can contribute to it. Just keep it simple, right? Check your ego. Collaborate, learn, share. Again, all these things. I think it's pretty well known. So we don't want to dig too much into it. And finally, special thanks to all the open source stuff. Special thanks to you, Jason. I mean, we've learned so much from you just by looking at your stuff. So thank you so much. Yeah, that's it. Any questions?